I'm Kevin. Welcome to my cave. Now that this channel has been up and running for a while, I noticed that I've been getting comments with questions like, why did you need to use a polyester capacitor there? Or, I don't have a 2N4401. Will a 2N3904 work? Almost all my videos use what the engineers call jelly bean parts. These are a few sorts of parts that you use over and over. The distributors stock them in quantity. If I needed 100,000 for a production run, I could probably get them overnight. And they typically cost pennies. A hobbyist does the same sort of thing on a smaller scale. We keep a collection of jelly beans in stock. Whenever we can, we design with what we have. So let's have a look at what I use on these videos. First off, the passive components. For breadboarding with resistors, I have a cheap Asian kit of quarter-watt 1% resistors in all the E24 values from 1 ohm to 10 megohms. These are available from any number of suppliers on Amazon, AliExpress, eBay, wherever. E24 are the values that are usually used for 5%, but many manufacturers also make 1% resistors in those values. 5% is good enough for most of what I do. But the metal film resistors are more temperature stable and nearly as cheap. It just doesn't make sense not to use them nowadays. The kit I have came in a plastic box with the various values on snippets of tape. Once you unwrap the little bundles inside the box, the components don't all go back in. There's no way I'm searching through that mess. I find that what works for me is to use 24 drawers in my parts box and group the resistors by the 2 leading digits. So drawer 10 will have 1 ohm, 10 ohms, 100 ohms, all the way up to 10 meg, and similarly for all the other drawers. That way I can find what I need quickly. The big problem with these cheap resistor kits is that the leads are about 0.41 millimeters in diameter, which corresponds to about 26 gauge if you use freedom units. That's right at the limit of what my breadboard is spec'd to take. But they work well enough until trying to insert one turns it into a crumpled mess. When this happens, it's very hard to get the leads straight enough to go into the breadboard again. With it having been about a 2-cent part, when that happens, I just throw it out and grab another one. My breadboards are good enough quality that they always seem to grip the fine wires adequately. When I come close to running out, I buy a strip of 100 better quality ones of the same value from a manufacturer like Vishay or Yageo for a couple or $3. I usually look for the ones that have a 50 part per million temperature coefficient, since they're no more expensive than the 100 or 200 part per million counterparts. Their leads measure about 0.56 millimeters, or 23 gauge. They're a lot stiffer. Nothing happens if they brush against the bench, while a slight touch will deform the leads on the cheap ones. So those are my fixed resistors for breadboarding. You also need potentiometers, both linear and log taper, to make your turn the dial adjustments. I found that it's convenient to have them all on the same form factor, and of course to have ones that fit the breadboard right out of the box. I found that the PTV09A series from Bourns fills the bill. When I need a value that I don't have, I buy 10 or so, and so for most of my projects, I have what I need in inventory. The ones with 25mm shafts are about the right height to fit the knobs I use. Oh, by the way, there's a trick for getting these inserted in the breadboard. They really don't want to go in with the pins as they are. But if you take a pair of pliers and bend them outward a little bit, and twist each pin 90 degrees, they fit like a champ. The same trick of twisting the pins 90 degrees works for power semiconductors in the common TO220 form factor. And precision circuits always seem to need trim pots. I do the same thing I do with panel pots. When I need a value I don't have, I buy 10 and build up an inventory. Again, I like to have them all on the same form factor. I happen to like the Bourne's 3296Y ones. Their pin spacing fits the breadboard, and the center pin is offset. So when it comes time to have them in a PC board, they won't go in backward by mistake. Once in a while, I need a resistor bigger than a 1/4 watt. But I promise that when that comes up in a video, I'll tell you exactly what you need. I don't try to keep them stocked, so all the ones I have are leftovers from earlier projects. Okay, now for capacitors. I use several kinds. In the videos, I mostly try to specify when things are in doubt. But you can safely assume that anything up to a few hundred picofarads is ceramic unless I say otherwise. And anything a microfarad above is probably an aluminum electrolytic. The 0.1 microfarad caps that you see all over the circuits for power supply bypassing are all cheap ceramics. You need ceramic ones when you need low inductance and low series resistance, and don't care too much about the value as long as it's big enough. Power supply decoupling is the big use. But I also often need to add a capacitor of a few tens or hundreds of picofarads to compensate an op-amp or comparator that's decided to start oscillating. There's a higher grade of ceramic, labeled C0G or possibly NP0, that is accurate and temperature stable. Those are mostly used for radio frequency circuits, and I don't plan to talk about those for quite a while. Don't use ceramics in low-level audio signal paths. They tend to be microphonic. That word means just what it sounds like. They will pick up ambient sound and send it down your signal path. I've gone again with a cheap Asian kit here. There are a ton of them on Amazon and similar places. I'm pretty sure that they're junk. But for supply bypassing and op-amp compensation at audio frequencies, junk is all you need. They have the same problem with the flimsy leads that the resistors did. I haven't gone through 100 of any single value in the kit I have, so I haven't needed to restock yet, but I'd certainly look for ones with better wires. For timing applications and audio filtering, you need more precision than you get from a trash ceramic, and you need low leakage. That's where polymer capacitors shine. For most of what I'm doing on this channel, polyester, such as polyethylene terephthalate, PET, or polypropylene will both work. Surface mount needs materials that will survive reflow, such as PEN or PPS. Once again, I have a cheap Asian kit of polywana cracker caps in a lot of different values that I use for breadboarding. Once in a great while, I might tell you that you need a good quality polypropylene cap, usually for the lowest possible leakage or best temperature stability. I buy them when I need them. Now on to the electrolytics. These are for when you need a lot of capacitance and not a lot of precision. As long as it's big enough, we won't be fussy. Mostly in this channel, you'll see them as energy storage and power supplies, as brute force filtering on voltage rails, and as audio coupling capacitors. For the most part, aluminum, or aluminium for my international viewers, electrolytics serve nicely, and I have a big cheap Asian kit of those. I also keep a few capacitors in stock in higher capacitance or higher voltage ratings than the ones that come in the kit. I don't like pushing them, by the way. I'll look for a cap with a working voltage that's twice the highest voltage that I intend to apply. Sometimes I need an audio bypass cap, and I can't guarantee that one end is at a higher potential than the other. I keep a handful of 1 and 10 microfarad non-polarized, or sometimes labeled bipolar, electrolytics on hand for that. Some voltage regulator circuits are documented to require tantalum capacitors on their outputs. Tantalums are mechanically smaller than their aluminum counterparts. They're also more like ideal capacitors with less inductance, internal resistance, and leakage. But they have a distressing tendency to catch fire when abused, for instance, connected in reverse. They're also associated with never-ending civil wars in some of the nations that mine tantalum. I have a small kit of them on hand, but I try to avoid requiring them. While we're talking about passive components, I suppose I should mention inductors, but they're another kettle of fish entirely. They're the least ideal of all the passive components. All of them have a lot of series resistance and parallel capacitance, and various undesirable magnetic properties that make them the least used of the passive components. I keep a small kit of them, because I occasionally need one for a DC to DC converter, but they tend mostly to gather dust. I suppose I should mention the most passive component of all, wire. In addition to a collection of 22-gauge wire in various colors, I have a kit of pre-cut breadboard jumpers, and another kit of wires with DuPont connectors installed for making fast changes on the breadboard. These are more a quality of life thing than anything else. I could certainly cut and strip all my own wires and get results about as neat, but I like the convenience. And I think that's just about all I have to say about passive components for the moment. Next time on this little series, I'll get into the diodes and transistors. I hope you'll stay tuned for that. Until then, stay safe, stay healthy, stay curious, and take care of one another. Bye.